Welcome back everyone. In this lesson we're going to look at Python functions. Now functions are one of the most important things you'll learn in Python. They're what let you write clean, reusable code, and that means code that you can run over and over again with different parameters to achieve different outputs, but without having to write the code over again. In this lesson we're going to cover everything from the ground up, so we will start with what a function actually is, then look at how to define them, including how to pass data in using parameters, which makes one run of a function different to another run, set sensible default values for those parameters, and also handle variable number of arguments. We'll also look at the difference between a function that gives you something back and one that just does a job. And we'll finish by pulling it all together into a proper working script. So let's get going with some coding. So here we are in the coding screen. So what is a function? A function is basically a named reusable block of code. But instead of writing the same logic over and over again and rerunning it, you can just write it once, give it a name, and then call it whenever you need to. To define a function in Python, we first use the def keyword, okay, which means basically define. And we give the function a name, and we use open and close brackets to say that this is a function. And then we use a colon, and on the next line, indented, we do the block of code that we want to define as part of this function name. Now I've used lowercase with underscores, which is a Python convention, but it's really important that you get this structure correct. Because if you forget any of these key elements, i.e. the brackets, the colon, the indentation, the function will not be recognized and will not be able to run it. Let's run this particular function now. So if we highlight the call, which is the name of the function, and we use the open and close brackets, the parentheses, we see that it's printed welcome to the claims processing system, as we've stated inside our definition of the function. So that's just a very simple introduction to how a function is defined. So our function has no inputs at all. It's basically going to run the same thing over and over again. That's perfect for tasks like printing a header or logging something or fixed messages that we want to produce, or running a startup check, for example, in a procedure. If we wanted to run that function again, all we do is we just call that function name and it will do exactly the same thing over and over again. So if I did 4 times and I ran that, I'm just going to get the same output coming out every single time because we haven't passed any parameters to that particular function. Now the reason for this is because within those parentheses that define that function, we haven't listed any parameters in there. So this function is not expecting us to pass any arguments. Arguments are basically the values that you're going to pass into the function. And the parameters are basically the list of variables that it's going to deal with. So in our case, we've got def, greet claims team, open and close brackets, and nothing's inside there. If we wanted the function to do something different each time, because we're going to pass different values into there, then we have to define parameters for that function, and we have to pass different arguments to that function so that it acts differently each time it runs, based upon those values that we're passing it. Let's demonstrate this. So on the screen now, I've got a new function here, and it's called display claim. And display claim has 3 parameters: claim ID, loss type, and channel. And when it gets those 3 parameters, it prints each of them one by one. And then it follows with 30 hyphens. Now, in this call here, in the first call that we're doing to the function, we're calling the function by using the name display claim, and we're passing 3 arguments: claim 002, theft, and online. Okay, so those will go in that particular order into the order of the parameters defined for that function. So claim 002 will go into there and it will get printed. Theft will go into the loss type and it will get printed. And online will go into the third parameter, which is channel, and that too will get printed. And then we've called this function again. Now, unlike our previous example where we had no parameters for the function, this time we're passing arguments in, and they're different for each call. So the function will act differently because you've got new values going in. So let's run this and see the output. So now you see that the output is different based upon each call because we're passing different set of arguments each time we run this function, or we call this function. In the first round, we're sending in these set of arguments, and in the second round, we're sending these arguments, and you see the output is different. So that demonstrates the reuse of code and the value of a function, that it will print a different output based upon how we call it or what we pass into it. Now, this is very powerful because when we've got something which is repeatedly done in a piece of code, but is dependent upon the values that we want to pass, we now don't have to rewrite the same code over and over again. We can just call that named function, and it will behave according to the values that we're passing it. Just note that the order of the arguments that we pass has to match the order of the parameters that are in the definition of the function. However, there is a way of bypassing that restriction. We can actually name the arguments that we're passing in. And how do we do that? So in this example, what I'm doing is I'm saying channel equals branch, claim ID equals claim 008, and loss type equals flood. Okay, now that's not the order in which the parameters are defined in the function name. Claim ID comes first, loss type, and then channel. But in this case, we're mixing it up a bit just to demonstrate that we can actually define the arguments and assign them to a different parameter in a different order in which they're defined in the function. So if we run this, we now get the output as we expected, even though the order is different to the way it's defined in the function, because we're actually naming each argument as we pass it. Had we left off the actual definition of each of these arguments, we would have a very different output. So let's demonstrate that. You see now the claim ID is picked up as branch because it's expecting that to be the first argument or the first parameter that's received. And that's not the case. We know that claim 008 is actually the claim ID. But by defining each of those arguments, being explicit with them, we can then disregard the order in which the parameters are defined in the name of in the actual function definition. So it's very useful to do. Let's move on to some other examples now. So far, our functions have printed things, but not handed anything back to us as a result of the function's definition. In many cases, you'll want a function to actually compute a result and then return it back to whichever part in the code actually called it. So you can then use that returned value elsewhere in your program. That's what the return statement is for. So in this example here, I've defined a function called calculate payout. Now, there's two parameters in there, claim value and excess. So the payout is calculated as the claim value minus the excess value. And if the payout is less than 0, we return 0. If the payout is not less than 0, it will carry on and it will return the actual payout. Now note there are two places where the return is in here, because if the payout is less than 0, it will just return 0 and then the function will just complete as soon as the return is hit. If the payout does not fall into this condition, then it will carry on and hit this return where it actually sends the calculated value back. So let's run that and see what we get. Okay, so the first time what we're doing, we're saying call the calculate payout function, and this time we're actually passing values in, and we've assigned the return value that comes back from that function to a variable here called amount. Okay, so we're assigning this variable the output of this function run. So we're passing two arguments, 3500 and 250, and they go into the claim value parameter and the excess parameter. And the calculation is done, and then we get a return value and we print that value. So in the first case, it works it out to be 3250, and in the second case, it falls into this condition where the payout is less than 0, so it just gives us a 0 output. So as you see, the function has two return points, and as soon as it returns, it exits the function immediately. Let's progress this a little bit further now. In this example, what it demonstrates is that Python allows you to return more than one value at once. In fact, this will return a tuple, and we covered tuple in earlier lessons. So what's happening here is that it's calculating the payout to be the maximum of either 0 or the claim value minus excess. The status is defined as approved if the payout is greater than 0, otherwise it's defined as rejected. And then it sends back, it returns the payout calculated value and the status, and under the hood it's sending back that tuple. We then print out the result of that. So let's run that. So in this case, we passed in 3500 and 250 as the excess. The calculation was done. The payout was greater than 0, so the status was set to approved, and both the payout and the status were returned, which we then printed. And you notice that we captured back the return value into the two variables, and that means it was captured into a tuple. So a little bit more advanced than the previous example, but you're getting the hang of it, that you're basically passing values in and then you're capturing the return values. Now there's an important conceptual distinction to be made here, even though Python doesn't actually strictly enforce this, and that is that a procedure is just a function that performs an action and doesn't return anything. But a function, strictly speaking, is something that computes and returns a value back to you. So if you try to capture the value of a function that doesn't return anything, strictly speaking a procedure, then you just get none, because that's what Python returns when there's no explicit return statement. So let's just demonstrate that. So you see there, we've got a definition of a function there, and it's not returning anything, so strictly speaking it's a procedure. And we've captured the result of running that function, and it's given us none, because it's not actually been told to return anything back to whoever called it or whatever called it. Just something to note, because it's something which you should understand generally when you're coding, whether it's in Python or any other language. Now sometimes a parameter almost always has the same value, but not always. Sometimes useful is using default arguments. This lets you have something to fall back on. If the calling routine doesn't provide an argument, the default then kicks in. If they do, it's just overwritten. Let me demonstrate with this example here. So let's have a look at the definition here for open claim function. We have 4 parameters in there: claim ID, loss type, channel, and an excess value of 250. If you look at the channel and the excess, both have default values in there, okay? We have a channel of online and we have an excess of 250, which means that when we pass arguments to this particular function, if we didn't pass the value for the channel parameter or the excess parameter, those two default values would then kick in. So let's run this particular function, or call this particular function, without the use of every single parameter. Okay, so in the first example, we're going to run OpenClaim, but we're going to pass into there. And now we're not defining what each of these arguments are, so it will be based upon the order in which they're defined in the function definition. So we're passing claim 010 and theft. So those will go into these corresponding parameters, claim ID and loss type, okay? And if we run that, let's just first comment out these other two so we don't get any confusion. We get claim 010 being printed. We get a loss type of theft, which we passed in. But the remaining two parameters, which are then used to print, which are then printed as well, will be the default values that are in the definition for the function, okay? Because we didn't provide any arguments for those two parameters. Let's do the next one now, where we are providing a channel value, but we're not providing the excess. And again, when we run this, we see that the channel is being passed, and because we didn't provide an excess, the default is then being used. So if we now then just run this final one where we've specified every single argument for the parameters, where we're given an argument for each of the parameters, and run that, we now get these overriding any of the default values which have been set inside the function definition. So we've got branch as the channel in excess of 500. Even though there's a default value defined, they are overridden because they're being passed to the function. So that's very useful to ensure that we don't get any problems with the running of the function, and we have a fallback value for those particular parameters. Now there's one rule that you need to be aware of, okay? And that is parameters with defaults must always come after the parameters without the defaults. If you put a default parameter first, Python can't figure out which argument matches which parameter. It'll throw a syntax error. So always remember that rule. For the parameters with defaults after the parameters without. I want to cover the topic of args and kwargs, okay? Now, sometimes you generally don't know how many arguments you're going to receive in a function. Python has two special syntaxes for this. One is called args, which collects extra positional arguments into a tuple. And the other is kwargs, which collects extra keyword arguments into a dictionary. Now these look a little bit strange at first, but let's just work through them slowly. On the screen there, you see a definition of a function called log claims. And we've used this notation where you've got a asterisk before the parameter name. And that means we can be passing in any number of values into that particular parameter, okay? So in this function, what it does, it goes and prints the length of that particular parameter. So it tells you how many claims there are, okay? So how many values have been passed into that parameter. And then what it does, it goes through each value in that parameter, iterates through it using the for loop, and print each one. So if I run the first one, it's only got one value, so it just goes and prints it. If I run the second one, it runs through each of those and it prints each of them. And that's just using one parameter definition, but because we've used this asterisk before it, saying it's an args parameter, it then knows how to handle it. And this is really useful when you don't know how many values are going to be pushed into a function which can handle multiple values. And that's key, that the function has been defined to be able to handle going through an iteration. Now we can extend this to something called kwargs, okay? Now in kwargs, what we have is that we have named arguments. So let me demonstrate that. Now in kwargs, keyword arguments, 2 stars are used to capture the keyword arguments, okay? So now what we've got 2 parameters in there, one claim ID and the other is details. Now we've got 2 asterisks before that, okay? Which means we can pass into there multiple values with keywords. So in this example, I've defined this function called create claim, and I'm passing into there claim 002 as my first argument into the claim ID parameter. And then what I'm doing is I'm passing in keyword arguments, channel used, claim opened, and the loss. And they'll all end up in this particular parameter. So that what it will do is print the claim ID, and then for everything in the details parameter, it will go through as a key value pair. And the key will be the keyword, and the value will be the actual assignment to that particular key. So let's run that. So you see there it's printed the claim ID, and then it's gone through in a key value pair for each of these keys and values that have been passed in to the details keyword argument into the details parameter. It will go through these keyword arguments and it will print each one, the key and the value. The best way to learn this is actually practice. So go ahead and manipulate the code. It's all provided for you, and learn how it's working through them. And it will soon be really clear. So it's a progression on from what we've done before, but there are scenarios as you come across in your coding career, you'll find it very useful to understand this. So just as a summary, let's try and put some of the features that we've learned so far into a script and just have a look at how things interact. So in this particular script, we've got a number of functions in here. And what's happening is that run claims report is our execution. Okay, so this is a function that we're going to run, and we're going to put claims data into there. Okay, and claims data is coming from this dictionary that we've got created at the top, consisting of key value pairs. Now, run claims report is our starting place. We're passing in our argument of claims data into this parameter claims. It's going to go through each one, take the result, and print the result there. And the result comes from running another function, which is further up here, called process claim. That's taking the value that we're passing here, pushing it into this parameter, and running this function. And this function itself is doing a calculation using yet another call to another function. So you see how each of these are connected, and how by having a breakdown into different functions, we're able to encapsulate different functionality into individual function units. That makes our whole maintenance far easier in future if you want to change one small part of the whole process. So if I ran that, so we see 3 outputs there, and it's gone through each of those steps, calling each function to deliver the result that we need and passing it back through until we get a result at the end. Now this script will be included in the resources, so have a look through it, run it, change what you want to, and understand how it all fits together. It's fairly simple. It's only when you start going through it step by step that you really understand everything. And it's a good way of going through some of the features that we've discussed in this lesson. So let's wrap up our section on functions just by summarizing what we've covered. So we use the def to define a function, and the open and close brackets, the parentheses, to call it. Parameters let you pass data in, and return sends data back to wherever it was called from. A procedure does the job but returns nothing. A function actually returns the value. Although Python doesn't strictly enforce these particular naming conventions, we just use function. Default arguments make your functions flexible without extra code, so we can have default values assigned within the parameters. Args and kwargs handle variable number of arguments. And in real scripts, small focus functions that call each other is the goal here. It's much easier to understand when your functions aren't overly complex and overly long. Try and keep things simple. Simplicity allows you to maintain the code effectively if you ever have to come back to it. That's all I want to cover about functions for Python. I'll see you in the next lesson.